In the figure below, ABCF is a rhombus and ACD is an isosceles triangle. So angle CD is 38 degrees and ECD is 46. So 46 is just this one, ECD. So you need to find angle ACD and angle ABC. Okay, so again, when you read a question, whatever information is given to you, and if you can annotate things down onto your diagram, that will be very, very helpful when you move on to solve your angles later on. Okay, so firstly, ABCF is a rhombus. Okay, so if ABCF is a rhombus, take note, all four sides are equal. Okay, so if you like to go ahead and do this, use double stroke because single stroke is already used for the triangle there. Okay, so these four sides are equal. And bear in mind, a rhombus has two pairs of parallel lines. All right, so AF and BC are parallel, AB and FC are parallel. Okay, now ACD is an isosceles triangle. Okay, so ACD, luckily they already labeled these equal sides for us. This one, so it's isosceles. Okay, then we can go on to start to think about how to go about solving this question. Okay, so firstly, I will start off with using the isosceles triangle to begin working around my angles because currently in your triangle, you notice that a lot of angles are provided in the triangle. Okay, so this is 38 degrees over here, which means that in this isosceles triangle, I can be sure that this corner here is also 38. Okay, so if you're aware, please annotate that down straight away. Now with that, I think it's pretty straightforward. Okay, so if I were to look at this isosceles triangle, I already have the two of the angles that 38 and 38. So what's left is finding this whole thing. Okay, this whole angle ACD, which is what we want for our first answer. So angles in a triangle, corners all add up to 180. So to find angle ACD, just take 180 minus the 238. So this whole stretch is 104 degrees. And there you go. Okay, whatever angle you found, write it back down onto the diagram. Now let's go on to find angle ABC. So ABC is this one at the corner here. Okay, so how do I go about solving this next? Okay, so if you notice my 104 degrees and the 46 is actually part of the 104 degrees. So I'll start with this. Okay, this will be my starting point for part B because I have more information here. All right, so then of course, which means that I can go on to find angle ACF. ACF is this corner here, right? So angle ACF, simply take the 104 degrees, you subtract away the 46 degrees, right? To get your ACF. So 58 degrees will be over here. So we're going to draw that and write down 58 degrees. Okay, now the next thing is, how do I go about continuing from here? So once I know this 58 degrees lies here, you can actually make use of the parallel sides to your advantage, the Z shape, the Z property. So you see, this 58 degrees, if I were to highlight out the Z property, I realize that this and this angle will be the same. So if this is 58, means this angle here will also be 58 degrees. Okay, so I'm slowly making my way into working inside the rhombus because the parallel sides in the rhombus will be very, very helpful. Especially when you have diagonal lines cutting through the rhombus, Z-shape property is the most useful usually. Okay. Now, and what's next? All right, so I have this 58 degrees. And from here, what I can observe is that in the rhombus, this triangle will be isosceles. Now, how do I know that? Because like I said previously, a rhombus has four equal sides. All right, so just now we have indicate the double side. Okay, I accidentally erased that. So your double sides here will tell you that ABC is isosceles triangle. Now, which means that if this is isosceles, here 58 degrees, which also means here, this corner must also be 58 degrees then, right? Because in an isosceles triangle, you have two equal angles here. And I believe from here, we all know what to do to find angle ABC. Sum of angles in a triangle add up to 180. So simply 180 minus those two 58s to get your angle ABC. And that's it.